No new formulas. I told you that. No new formulas. We're just going to use the ones I gave you a little differently. Okay, you're going to see them pop up, and I'm going to need them right away. So what we're doing today, if you take a look at 1A, that figure, I have no idea what that figure is. Could be a trapezoid, who knows? But I don't know what that figure is. This is called a composite figure. It's basically a figure I can't name and I don't have a formula for, but I can break it up into shapes that I do have formulas for. All right, so that's a composite figure. So there's, in part A here, in the shape in part A, there's a bunch of ways we can cut this up. And I've also seen some people in the past, I'm not going to do this way with you, but you could also add on a little right triangle action there and figure out what the area is. I don't like to add on, I like to break it up. All right, so can you guys see a vertical line I could possibly draw in and get two figures we're familiar with? Or heck, even a horizontal line I could draw in and get two figures we're familiar with. So hopefully you see that, because somebody's going to make a big decision right now. 3, you want me to draw in the horizontal or the vertical line?
Oh, the horizontal.
Sure, you got it. Horizontal it is. So I'm going to draw it from this vertice over. And take a look what I formed. I formed a trapezoid on top. And I'm going to add that to the rectangle we created on the bottom. That's what a composite figure is. Now, hey, do I just have to draw in one line? No. Like I draw this line in and maybe a figure on the, you're not familiar with the figure on the top. All right, draw another one in. And now you got a triangle and another rectangle. So you draw as many in as you can, or it's as needed. We're going to stick with that yellow line. All right, trapezoid. You better be familiar with that formula by now. I'm not even going to bother writing it. Height. What would be the height of this trapezoid we've created on top? What is the height of that trapezoid you have created? Oh, 3 again. 7, yes, 12 minus 5 times, how about the bases to that trapezoid? Because I got to add them together. What are the base lengths for that trapezoid? 7. What was the first one? 8 and 15. Thank you. So there's the trapezoid. Now let's add the rectangle on top. 26, length and width of the rectangle. Oh, that son of a gun. He owes me one. 11?
15 times 5.
15 times 5. Good work, everyone. You owe me there, boss. Your number just came up.
I owe you?
Yeah, you owe me one. You don't know when, but you're going to owe me one.
Okay.
All right?
All right.
When you're ready, directions say round to the nearest tenth. Let me know when you're ready. 7. 155.5 square inches for that composite figure. So we all feel comfortable there? I'm not going to do part B and C with you because I'm going to let you do that in your groups. There's no reason for me to stand up here and say, let's divide it up into this. Let's do the formula again. You guys can grind away. There's another type of problem I need to work with you on, and that is part D. Go to part D, please. Not a composite figure, but what I call shaded regions now. How do I find the area of a shaded region that's not a figure we're familiar with, and it's not a composite figure I can break up? It's just find the area of this shaded region, and that's what I'm asking for in D. Polygon MBATH. You may have your own way of going about it from previous years. Here's how I deal with finding the area of a shaded region. I take the area of the whole darn thing first, which I should be familiar with. That should be a shape I'm familiar with. And then I subtract out the area of, what am I going to write here? I take the whole thing and take out the, well, it might not be a triangle, but anything that's unshaded, yes. And hopefully that's a figure you're familiar with as well. All right, what's the whole thing here? 18, what's the whole figure? Rectangle, thank you. So that's going to be length times width. I forgot to label my parts here, 6 and 15. All right, length times width of the rectangle. What values do you have for me? Woo, 20?
6 times 15.
6 times 15. I don't care, Bridger, thank you. 6 times 15. Stop trying to show off. And what figure is the unshaded? The unshaded would be the 11?
Triangle.
Triangle, that's 1/2 base and height. So what are the base and height of this unshaded triangle? 9, what values do you want me to plug in? Base and height of the unshaded. Unshaded. UN shaded. Yes.
4.6.
Would be the height, and it's drawn to a base length of 15. Why 15? Rectangles. Thank you. Opposite sides are congruent, and there we go. So that's how I can find the unshaded part. Take your time. Let me know when you have it. 11 again.
We're looking like 2, which is 55.5.
We are looking like that. Yep. All right, so we had composite. We had shaded region. Last problem I want to do with you is in the homework, actually. And that is, you find the shaded region. Now I want you to do something with that number. Okay? So an actual word problem here. So go to tonight's homework. We're looking at number 2. The old rock solid concrete company. So I find the shaded region, now do something with it. So let's look at part A. Let's look at part A. Find the area that must be paved. What's getting paved? Everything but the fountain, AKA the shaded region. All right, so let's find that area first. So again, what's the whole figure? The whole thing is a 17. How are you going to find the area of it? Which would be? Thank you. Subtract out the 36. One job. Minus, what's the unshaded figure? That would be a 13. Circle. No excuse. You either know the formula, or if you don't, you look back on your formula sheet. Pi, R I'll talk about in a second, squared. All right, how about that radius? Look in the givens, please. If you didn't read the whole problem yet, read it. It's there. The radius isn't, but it'll get you there. How about the radius length? 18. 4, diameter was 8. Cut it in half. We're good. Okay, so that's how I'm going to find the area of what I need to pave. And directions say near square foot. Go ahead, type away. 15 times 36 minus 16 pi. When you're ready, nearest square foot, 16. 490 square feet. Good. Now let's do something with it. I'm going to ask you to do something with that shaded region. How much is it going to cost me to pave it if this company is going to charge me $8.95 per square foot? Now here's what happens usually when we do these problems. I get half the class that's confident. They're like, I'm going to multiply, I'm going to divide. They're confident in what they need to do. And then I have the other half of the class that's kind of like, honestly, I would be guessing if I had to multiply or divide. I'd just be guessing. I don't want you to guess. All right, I want you to be 100% confident what to do with that $8.95. So if you're ever unsure of yourself, do a proportion for you. Do a proportion. What do I mean by do a proportion? Well, we know what they look like, right? Right across, I write the fact that the problem gave me. $8.95 for 1 square foot. I start my proportion off that way. Whatever they give me, that's the fact. Underneath, I keep the same units together. $4.90. Dollars or square feet? Square feet. So it goes with the square feet. And I'm trying to figure out how much money do I owe you. So if you're unsure, because some problems you multiply, some problems you divide, don't guess. Write a proportion. And as we cross multiply, doesn't it become very easy now? What do I need to do with that $8.95? I cross multiply. And notice there's no rounding directions because you're finding money here. So it's assumed you go nearest hundredth, right? Nearest cent, as they like to say, nearest cent. Don't be unsure. Write a proportion for yourself. When you're ready, 25?
$4,385.50.
Okay, couple things here before I let you go on your own in your groups. Couple things. Going back to this problem, notice I used the 490 and not the non-rounded answer. The reason being is if they ask you to round in the first part, use that rounded answer. Now let's say I totally, where are we going? Can I do this? That was the only question. There was no part A. It just said, how much money does it cost to pave it? Then I would use the non-rounded answer. Okay? But if they ask you in a part A to round it, keep transferring that rounded answer all the way through the problem. Versus, everyone see what I'm talking about? If I just gave you this problem, didn't ask for the area, then you would multiply $8.95 by the non-rounded answer in your calculator. We good? Last thing, whoa. We got to have a life conversation. All right? A life conversation. When you look at number 3, we're not doing this. You'll do it later on in class. It is asking you, how many bags of wood chips do I need to buy? All right, how many bags of wood chips? Now, you're going to do a bunch of calculations, and at the end, you're going to have this long decimal on your calculator. Now, let's say we take a little field trip to Hewitt's, Lowe's, Home Depot, and we walk in and we say, hey, look, I need 12.5682619 bags of wood chips. They're going to laugh you out of the place. You can only buy whole bags or whole quantities of items. Everybody good with that? So don't raise your hand. Why isn't there rounding directions? Because you can only buy whole items, quantities of things, all right? Not a partial bag of wood chips. So please remember that as you answer this question later. All right, you're going to go back to your groups. Or you're already in your groups. You're going to go back to your notes, excuse me. You're going to go back to your notes. You're going to finish parts B, C, and E. I will have the answers written up on the board. You'll check them. Once they're good to go, you start the assignment for tonight. Get those up. Whole bags of things.
It's 31 minus 22.
I just, bro, I literally see it on your desk.
Oh yeah.
John?
I said yes.
Last box to your right over there. All right, I get it for you, but we know you can easily get there.
You don't need that.